Dear all, welcome to this virtual Science Setu program. We'll very shortly begin our program. We are waiting for our executive director to join us. Kindly have patience. We'll be starting very soon. Good afternoon, one and all. A very warm welcome to everyone. Today we are having this virtual Science Setu program. Due to the ongoing pandemic, we will be having a series of Science Setu program virtually. I would like to thank all the faculties and scientists from Translational Health Science and Technology Institute for sparing their valuable time for this event. I am also very thankful to all the participating colleges, the teachers, and the students for attending this session. Today, along with the virtual Science Setu program, we are also celebrating National Science Day. This National Science Day is celebrated every year on the 28th of February to commemorate the Raman effect, the discovery of Raman effect by Nobel laureate Professor C.V. Raman. Now we'll begin with our program. The very first talk is by Dr. Suchitra Gopinath, and she'll be talking about the importance of science and its role in society and also the research opportunities. Over to you, Dr. Suchitra.
Can you open my presentation? My presentations. Yes. So, say to Dr. Suchitra. Yeah. And this is for going. Keep it to full screen. So, good afternoon, everybody. It's a pleasure and an honor to have several colleges joining us today for this event of Science Setu, the very first of the series. And you will see that the selection of topics that we have chosen is very much in line with the theme for the National Science Day, which is the future of science, technology, and innovation, impacts on education, skills, and work. So what I'm going to give you a brief idea about is the importance of science and its role in society. Given the excess of information that we are bombarded with currently, thanks to social media platforms and everybody's own version of their of scientific facts, it becomes necessary to revisit and recontemplate what is it that we are defining as science or the scientific method. Who would have thought that the discussions which were being held in 1948 on how to define science or scientific method and was published in Science, in the Journal of Science, by a very famous professor by the name James Conant, was the result of what is it that we're actually calling as science. So science comes from the Latin word scire, which means to know or to learn. And so the result of these discussions was that they agreed that all individuals who passionately believe that all rational and unprejudiced inquiries are considered as scientific. Women and men who are engaged and trained in science effectively ask for evidence-based claims. And these claims are to be evaluated by experts or scientists who have also been trained in order to attest the veracity of these claims. Inbuilt within the spirit of scientific inquiry is that theories are open to challenge, and obviously from equally validating and robust scientific counterarguments. But the fact of the matter is that once they are out there, they cannot be ignored. And inbuilt within, again, within this whole framework, scientific framework, is that there really is no certainty and there are no dogmas. Now, can we go to the next slide, please? So the question of why is science important is kind of something that we all think about, and it goes way beyond very obvious measures such as developing cures to diseases or even the technological advances that we are seeing around us. The most important thing that we can think of is that it improves life quality and safety, and by doing so, it reduces inequalities between the developing world and the developed world. It's also a determinant of socio-economic progress. More than anything else, it elevates the thought of an individual and increases your mode of functioning. It helps also helps the human species understand to live in harmony with the environment and the other species. And the most important thing is that it gives importance and emphasizes fact and evidence based claims. Uh, Most often, when we think about science, many people think about it in the context of career, and also, and then the kind of advice that you get generally while pursuing a career is that would you be engaged in basic or applied sciences? So, traditionally, there has been this divide between primarily basic sciences, which studies the fundamental laws of nature, in a free search for progress of pure knowledge, and is secondarily applied science on which depends more on practical advantages like medicine, engineering, and industry. Now, these two categories are consistent with a very traditional mode of thinking, and it was there was this professor by the name Venkatesh Narayanamurthy in Harvard University. He was the dean of the School of Engineering and Applied Sciences in 2008, who called for the abolishment of this kind of a very hardcore separation between uh, basic and applied sciences. He said that that is a far too simplistic model. It's a linear model. He says that discovery goes both ways, while inventions draw on scientific knowledge and scientists gain insights from new devices and applications. So Narayana Murthy proposes organizing science as a cycle that moves from discovery to invention and back again, which is a highly non-linear model because they feed onto each other in a cross and interdisciplinary sort of network. The second thing that he emphasized is that communication between scientists and community is extremely important, for it is exactly this attitude that is necessary to dispel myths, conspiracies, and unfounded beliefs. We also have to remember that there is something called a scientific progress, as we have seen in the current pandemic. The lack of immediate explanations and fixes have left voids quick to be filled in by people out to make a quick buck. Therefore, as a society, we need to take a pause, allow science to go through through its time and through its process, rather than jump to the alternative, lacking any empirical data. There is no other better way to remind ourselves of the importance of science than simply look at the world around us and the achievements that have been made. Even if we just look at the life sciences discipline alone, and that is just from the last year to this year, we can take a look around us and see that the number of achievements that have been made are simply astounding. The research and the strides that have been made by scientists in their quest to understand the novel coronavirus has simply been unprecedented. What we're showing here is just highlights of the scientific discoveries that have been made. There have been many more, but these are the ones that deserve mention. So the other thing that you see on the left side, for example, is researchers published findings showing Google's DeepMind artificial intelligence system that outperformed six human radiologists in spotting abnormalities on the X-ray images. This showed that the artificial intelligence system was able to perform better than accomplished scientists in detecting cancer. Then we have separately in the University of Pittsburgh, who also developed an AI program to recognize prostate cancer from tissue slides. The third thing that you see just below that is an example where there was no fixed goal in mind, there was no disease in mind. It was almost fortuitous, it was almost serendipitous that Dutch scientists who were just dissecting and probably just looking around for something else discovered a tiny new organ in the human body, which they called as tubarial glands. And this is probably this is the one of the best sort of example of a new organ that is being just discovered almost by mistake. And what this organ does is that it is known to lubricate and moisten the oropharynx and the nasopharynx regions. Then comes the famous example of the CRISPR-Cas9 technology that was recognized for a Nobel Prize in Chemistry in 2020. This is the best example of scissors, molecular scissors used in vivo, and it was used in surgery to address a blindness causing gene mutation that keeps the body from making a protein needed to convert light into signals. In these cases, a gene replacement therapy was not an option, so they decided to edit or delete the mutation. What you see at your bottom is another fantastic discovery called as xenobots. It's called as xenobots because xeno comes from the word Xenopus levis, which is the African clawed frog, and bots refers to small robotic instruments. So what they did was they took these live embryonic stem cells from this frog and then they allowed it to grow in vitro to form heart and skin, embedded them with tiny chips and called them as supercomputers. These small living bots, which were simply millimeters in size, were able to move within the human body. They can survive for many days devoid of blood and collectively work in groups. They also, so xenobots behave pretty much, they're just a pink blob of flesh and they don't look very sophisticated, but they're able to perform multiple tasks like get rid of radioactive litter, remove microplastics from water bodies, deliver drug substances, or even remove plaque from our arteries. Further on, you can see one of the other big achievements was lab grown meat to cater to a ever expanding population. And then on the top that you can see is the introduction of the bacterial strains of Wolbachia in Aedes aegypti, which has significantly reduced the virus multiplication in the carrier mosquito. This reduced the disease dengue by 77% in different regions of Indonesia. Uh, they had accomplished this task by setting off mosquitoes with Wolbachia bacterial strains, which can effectively cease from spreading via viral infection. Also, there were other discoveries that you see on the right, such as plastic degrading enzymes, development in cryo-electron microscopy, and the other stuff that you see that is on the right side of the slide. It's not moving forward. Yeah. So this is as far as the Piyush, can I have this panel moved so I can see what's on the right side of the slide? Yeah, because I've been reading it out from there. So from there, we switch gears a little bit from science around the world to an overview of biological research in India. And there you see a quote from Jawaharlal Nehru, which is that it is science alone that can solve the problems of hunger and poverty, of insanitation and illiteracy, of superstition and deadening of customs and tradition, of vast resources running to waste, or a rich country inhabited by starving poor. Who indeed could afford to ignore science today? At every turn, we have to seek its aid. The future belongs to science and those who make friends with science. What you see on the left is an example of the amount of money that India's R&D has spent relative to its GDP, the one in red. While it has been so far less than 2%, or less than 1%, the good news is that from the Union budget of 2021 for science, there has been a hike in the funding that major departments will be receiving, which is around 13% or more in the money. There's also been the creation of the National Research Foundation, genomic initiatives. Let's see what's below that. The development of various plant varieties. And the sort of the goal for by 2022 is to spend at least around 2% of the GDP for R&D. So in terms of the international standing and collaborations that India has, this is from a study from Nature that India's position at number 13 in the world puts it amongst the global leaders in producing high quality science. With this ball and stick model that you see on the right shows India has very strong international collaborations with the USA, followed by UK and Germany, with equal partnerships in these collaborations. The thickness of the line shows you the strength of the collaboration, and the size of the sphere shows you the size of the country. What also came out from this study was that India has more international collaborations than it has national collaborations, and therefore there is a need to strengthen collaborations within the country and put it on par with the ones that we have with the international community. Then comes the question of our scientific workforce, which we find is many of the students who are unaware of the opportunities that are available after you get a PhD. So if you look at the, get an overview of the education system in the country, there are currently at least around 40,000 colleges. Of the 1,000 universities, central are 54, state 416, deemed are these are universities that are accredited and have a autonomous some level of autonomy, around 125, private 361 private universities. The institutes of national importance are around 159, and out of these, if one looks at the institutes that are doing life sciences and have a standing which is on par with international standards and recognized outside, there are roughly around 19 of them, which grant master's and PhD degrees. There are 23 Indian Institute of Technology institutes, of which less than 10 offer degrees in biology, and 7 in Indian Institute of Science, Education and Research institutes. Now, many of the students who are trained in in this process, many of them are under the impression that academia is the only career that comes out of this kind of a training. And in a recent study, they showed that the engagement of academics with industry, which is an extremely important arm, is just 4.7 to 10. This raises the need to strengthen innovation, enrollment, and research capacity. And indeed, the movement of the current government has been in this direction. There are multiple fellowships that you can see that are listed down here from the government, which are intended to strengthen the industry academia support. The last slide that, no, this is the second last slide that I would like to sort of emphasize on is that scientists have multiple avatars. Once you get your PhD, it is not just the role of a lab investigator that you see down there, where people perform experiments in labs. You also have the opportunity to go into the wildlife sciences, ecology, and function as an explorer. You could also be involved in product development and innovations and become an entrepreneur. If you are more savvy with the software and information technology, you could become a developer. If language interests you, you could also become a communicator or a teacher for dissemination of knowledge. In order to become a policy maker, you would have to have some understanding of the law, government policy, as well as scientific evidence. Or you could even be a service provider where you specialize in a particular technique and offer these services to other institutes. These are only a fraction really of the various avatars or various career opportunities that comes out of doing a PhD in science. And this is an example of some of the world-class institutes that we have in the country that are doing life science research, just to give you an idea of what's happening. So with that, I kind of end my talk, and just to make the point that in short, science is indispensable for progress, and its presence and its progress is an indicator of a well-functioning society. By investing in science, not only are we investing in our own society, but also in the sustenance of our own species. Thank you.
Thank you, Dr. Suchitra, for this very valuable insight about the importance of science and the role it plays in our society, and also about the various research opportunities. We are honored to have with us, amongst us, Professor Pramod Garg, Executive Director, Translational Health Science and Technology Institute. He's been a very busy man, so I would request him to enlighten us with some of his words.
Thank you, and good afternoon, everybody, dear colleagues, teachers, students of the participating colleges. Uh, Today, as you know, we are celebrating the Science Day, which is actually done on February 28th in the memory of Sir C.V. Raman, who discovered, as all of you know, the Raman effect, which is used even to this day in many, many applications. And this year's theme is Science, Technology and Innovations, Impact on Education, Skills and Work. As a part of National Science Day, I'm happy to see all of you participating in this virtual Science Setu program. The Science Setu program was initiated in 2014. It's a measure to address the problems of paucity of teaching resources in higher education institutions, leading to a lack of connectivity between academic scholarships and teaching. This program provides a platform for undergraduates from different colleges who can interact with scientists at THSTI and understand the research activities going on here as a part of larger research ecosystem. Engaging students and scientists in outreach activities is a direct way of increasing young students' awareness of ongoing scientific research. These programs will also help students in shaping their career as a researcher, independent researcher in future. For scientists, it gives an opportunity to showcase their work to youngsters and thus sow the seeds of curiosity and develop a flair for solving problems affecting our nation. It's important that students get access to practicing and thriving scientists, which will help them to increase their interest and enthusiasm and also provide them information on career development. The interactions in science are very important, and I think this is a very good program to conduct. Science Setu has been implemented by THSTI for many years and has benefited a large number of youngsters. In the past, faculty and scientists from our institute has visited various colleges for scientific interactions. So there is a two-way program. The scientists and faculties go from THSTI to other colleges, and also there are visits by college students to THSTI through a program called Shadow a Scientist. Shadow a Scientist program is important. In this program, undergraduates have been coming to THSTI and closely interacting with scientists here. And thus, this engagement, students do hands-on training in the lab, which is very important because once you read it in the books, you just have some idea. But when you're actually in the lab and you have hands-on training, this definitely allows you to understand things in a much better perspective. Due to the ongoing pandemic this year, you know, this event is being held virtually, and I don't think we have a hands-on physical shadow scientist program this year, but I'm sure in the coming months or so, this pandemic should wane, given the fact that vaccine is being rolled out to the entire country now, to a large section of population, and I hope next year onwards, we can have physical meetings and such programs should happen. The credit of science goes to, the credit of progress in the country goes to science and technology in a much broader context. So if you look at the progress of a country, one has to be self-sustaining in terms of food, that's number one, shelter and health. Now these are very essential component of any society. And health depends on innovations and progress in science. And this current coronavirus crisis has shown you that this is how it has resulted in a large number of people getting affected, a large number of people dying of the disease, not only in India, but across the country, across the world. And this resulted in depression in economies. At an individual level, people have lost jobs, they have become poorer. At a level of country, their economies have gone down, the GDP has gone down. At the level of the world, also there is shrinkage of world economy. So what has come to the rescue of all this is science. Through science, we have understood how coronavirus occurs, what's the virus pathophysiology, what is the immune mechanisms affecting clearing the viruses, and that is how people have come up with vaccines in 6 months' time. This is amazing. Vaccines take years to develop, but this time you have more than 150 vaccine candidates in the world. In India, we have two which have been developed in-house, and there are 3 more coming in. So this is how the power of science can be leveraged to improve the health of a nation. And India has responded to this crisis in a commendable way. And I think the credit goes to Government of India, Honorable Prime Minister Shri Narendra Modi ji, whose vision about Atmanirbhar Bharat and Make India program have resulted in this grand challenge being met by scientists in our country. And in this endeavor, Honorable Minister of Science and Technology and Health and Family Welfare, Dr. Harshvardhan ji, has contributed immensely to meet this challenge of coronavirus. Our scientists and pharma industries have also toiled hard to develop and manufacture these vaccines. And I'm so proud that India today is not asking other countries to supply vaccines. In fact, we are supplying vaccines to so many countries, some of them on complementary basis. So yesterday I was talking to a scientist in US and he said, in New York Times, you always find stories about India, negative reports, always. It is the first time that big newspapers are reporting so positively about India in terms of our response to crisis, in terms of developing vaccine, and also now in terms of supplying vaccines to the world. So this is very, very important. So my suggestion to all the young students, researchers is that you should engage more and more in science and technology, and this will definitely go a long way in the progress in the field of science and technology, which will make India one of the top countries in the world in biomedical science, in biotechnology science. We are already up there in terms of defense and space. You all know that. But in terms of biomedical science also, I think the previous slide showed we are number 30, but I think we are going to go up and be on the high table. Thank you very much. So enjoy and learn and re-engage yourself in science and technology. Thank you all very much.
Thank you, Professor Pramod Garg, for this very valuable insights about the various innovations which are being carried out and the way he has stressed upon the Make in India, Atmanirbhar. I would request all the youngsters to participate and to learn, and please do not stop learning. So there's a very good platform to connect, and we hope to have so many other sessions also virtually we will be conducting, so keep in touch. Moving on to our next talk, it is the advancements which have been made in science with a special focus India. So for this, we have Dr. Tarun Kumar Sharma with us. Dr. Tarun.
Slide Start. So very good afternoon all. So in the next few minutes, I will take you through the journey of Indian science and what are the various advancements we made. But before begin the actual science part, I would like to tell you a brief story. So I think all of you are familiar with this picture, which depict the Hanuman and Jamban Samvad. So this was the story from the Ramayana when Sita was kidnapped by the Ravan and Bhagwan Ram's army was actually looking for Sita. And in his army, there was only one person who could fly over the ocean in order to reach to Lanka. That was Hanuman. But he was not aware of his strength, his potential. So the other person in his army was Jamwant, who actually reminded him about his strength and the potential. And after realizing his potential, Hanuman flied away over the ocean and reached to the Sri Lanka and set the Lanka on fire, and rest is history. So why I am telling you this story? Because I want in this talk, I am playing the role of Jamwant, assuming that you all are Hanuman. I want to make you realize that who was your ancestor and whose descendant you are, whose blood is flowing in your arteries and veins, and whose DNA you are carrying. So in the next few minutes, I'll be talking about the various invention that our scientists made in the past and the recent time. So let's begin the science part. But before that, I would also like to highlight that what other part of the world think about the India, who we actually are. So You can see here the Mark Twain, who was an American author, and Albert Einstein, a famous scientist. So what they told about India was that Einstein said that we owe a lot to the Indians who taught us how to count, without which no worthwhile scientific discovery could have been made. Similarly, Mark Twain said that India is the cradle of the human race, the birthplace of human speech, the mother of the history, the grandmother of the legend, and the great grandmother of the tradition. Our most valuable and most constructive materials in the history of man's are treasured up in the India. So you can see that the contribution of Indians in the science are really massive. So, and I'll start with the Vedas. You know that there are 4 Vedas. It is the old Indian scripture, the Rigved, Yajurved, Samved, and Atharved. So Atharved is the Ved which actually deals with the science. So you can see these 2 images. So after finishing my PhD, I got an opportunity to read Atharveda. So I found one surprising thing, that the thing that we discussed or research on recently, all things were mentioned in the Veda. So you can see the certain number like 1, 7, and the 3 in one line. So number 1 actually represent the Kand, and 7 represent the Sukt, and the third number 3 represent the Slok. So in all these sloks, you can see that various things about the science was mentioned in the Veda, which was written long back, several thousand years ago, and it not only explain about the breathing process, the evaporation, about the photodegradation, how to get what are the various medicinal plants, and what are the various venomous organisms present on this planet. Like it also describe about that scorpion tail has the venom in it. So there are variety of science which is described in the Vedas. So now I'll talk about the various Indian scientists. So when I'll talk about all these scientists, you will realize that majority of these scientists, the past scientists, were basically the saints. So they were the spiritual person, but they have contributed massively to the science. For example, Aryabhat, he was a great Indian astronomer and the mathematician. He has given the zero and the number system. Without this, you can't realize that any worthwhile discovery in the science. You cannot calculate the normality, molarity, and even you cannot have the computer and the calculator. And he also gives an information about the revolution or rotation of the earth, that earth rotates on its own axis. So which was very significant contribution in terms of science. And then there was another scientist called Buddhayana. So Buddhayana was the person who actually calculated the value of pi, and all of you are familiar with the Pythagoras theorem. But before the birth of Pythagoras theorem, I would say even before the 1000th year of the birth of Pythagoras, he has given this theorem. And more recently, British scholar has realized that it was the actual contribution of Buddhayana, not the Pythagoras. And they have published this information in 1999. So you can see that the contribution is really significant. And then the Acharya Kannad, or he was also known as Alukya, and later his name was renamed as a Kannad because he has actually coined a term called Kana. Kana is the smallest particle exists in this planet that now we call atom. So it was actually discovered by the Acharya Kannad. Then the Nagarjuna. So Nagarjuna was a very great scientist, great chemist. He was kind of wizard in the chemistry and metallurgy. He wrote several books like Kakshapta and Jiva Sutra. So there are many books on the chemistry was written by Nagarjuna. So he has very first time established the process of extracting the metal in its pure form from its ores, and he has designed the various chemistry equipment. You can see here using the clay, he has designed various equipment, and he has established the process of making various medicinal drugs. And nowadays you are using the artificial jewelry which looks like a gold. So very first time he has established this mechanism and the process of creating the artificial coating on the jewelry. So that was the contribution of Nagarjuna. In addition to this, he has very first time described the process of corrosion and how metal get corroded. And he also studied the metals and their stability. Then now we have to talk about the medical science. So Shushrut, he was a great surgeon, and nowadays also he is considered as a father of surgery. He has written a book called Shushrut Samhita, and around 2600 years ago, he and other health scientists of his time conducted complicated surgery like cesarean, cataract, artificial limb, and he also did the brain surgery. And he himself designed various surgical equipments to conduct all sort of surgery. And nowadays, if you see, if I give you some example, you know about the Michael Jackson or other the celebrity who routinely use the plastic surgery, but the plastic surgery was actually invented long back by the Sushruta. In his time he did plastic surgery to the several persons. Then Charak is considered as a father of ancient Indian science of medicine. The person who has contributed massively to the Ayurveda. He has described various diseases and the method to diagnose them, and he has given more emphasis to remove the disease rather than simply treating the symptoms. He has given various fundamentals that is now in the textbook of Ayurveda. Those who study BAMS has to read Charak Samhita. Then there is another great scientist called Vagbhatta. So Vagbhatta was another legend in the Ayurveda. He was a student or disciple of the Charak, and he wrote two very famous books called Ashtang Hridayam and Ashtang Sangraha. So these two books are also the part of BMS curriculum. And very first time he has categorized Ayurveda into various subsections like internal medicine, surgery, gynecology and pediatrics, rejuvenation therapy, toxicology, and many more. And one interesting fact about Vagbhatt was that he has lived disease-free life till 135 years. And after that, he died with his own will. And all the methods and the sloka given by Bhagavata is very relevant in today's context also. That is why they are the part of the current textbook or curriculum of the Ayurveda. So these are the two oldest universities, so Taxila and the Nalanda. And when the other part of the globe was nomadic, India was having two very big university, and people from various part of the globe was coming to India and studied there. But due to the invasion, both these university was demolished by the invader. So that time the standard of Indian science was really great. And now I'll talk about some modern scientists, which include J.C. Bose, P.C. Ray, and other. So Acharya J.C. Bose was born in 1858, and he went to England to study medicine at the London University. And later on, he joined Presidency College, and two of his students was Meghnad Shah and S.N. Bose, who also contributed massively, that I'll talk about in upcoming slide. And his massive contribution towards the wireless technology. And in addition to this, he also invented one instrument called crescograph. So crescograph he has used to study the various stimulus in the plant. Very first time he demonstrated that plant can also feel, plant can feel the pain, plant can feel the happiness. So, and because of his contribution towards the wireless technology, last year Bank of England has featured his photograph on their 50-pound notes. And as you know that we celebrate Science Day in the remembrance of Professor C.V. Raman, and he has contributed massively to the physics. And one of the original and the major contribution was the Raman effect, which actually depict the scattering of light. He got the Nobel Prize for his invention and the discovery, and he was also awarded with Bharat Ratna. So Raman effect is something basically when light beam traveled in a medium, it get deflected and scattered, and that has happened because of the change in its wavelength. So nowadays this discovery played important role in various other science, including the diagnostics. So now there is a new concept that we call surface enhanced Raman scattering or SERS. Using the SERS spectrophotometer, one can detect various diseases and the various analyte, because each molecule give a unique signature when we use its SERS spectra. Then another scientist in this line was Acharya P.C. Ray. So Acharya P.C. Ray was again very great chemist, and he was born in the Khuna district, which is now in Bangladesh. He studied chemistry at the Edinburgh University, and later he joined Presidency College, Kolkata. And he was the founder of Bengal Chemicals and Pharmaceuticals Work. It was the first pharmaceutical company in the India, and he wrote a great book on chemistry called History of Hindu Chemistry, where he has elegantly described various chemical processes. Professor Birbal Sahani, he was a paleobotanist, so he has actually combined the geology and the botany, and he was born in the Sahapur district, which is now in the Pakistan, and he was graduated from the Punjab University. And you can see in Lucknow there is a institute, very big institute on the paleobotanist. It was named after Professor Birbal Sahani, and he has estimated the age of old rocks, and he also found that the Deccan Trap is in the Madhya Pradesh. So Deccan Trap was his original discovery, and he has also estimated the age of salt range around 40 to 60 million years. So Professor Meghnad Shah, he was also from West Bengal, and he got admitted into the middle school, which was 7 miles away from his college. So nowadays, we sometimes get discouraged with the problem, but if you study the biography of all these scientists, all have faced various challenges. Some was very poor, and other was not having access to very good education, but despite of that, they have thrived and contributed massively to the science. So Meghnad Shah has contributed to the astrophysics and the nuclear physics. He has started a journal called Journal of Science and Culture, and he has contributed to the nuclear physics also. And S.N. Bose. So S.N. Bose was another great scientist. He was a student of Sir J.C. Bose, and he has actually published an article called Max Planck's Law and Light Quantum Hypothesis. He sent that article to Albert Einstein, and Albert Einstein was very impressed by his scientific intellect, and he has published this article in a German journal. And later on, in collaboration with Einstein, he has developed a Bose-Einstein condensate, and he has also established the fact that in the universe there are only basically two elementary particles exist. One is the fermion, and other is the boson. So boson particle was named after the S.N. Bose. And in this series, the next scientist is Professor Panchanan Maheshwari. So Professor Panchanan Maheshwari is a very famous biologist, and you can read his contribution in the botany textbook. Before him, nobody think that you could do plant fertilization in the test tube. So he was the first person who invented the technique of test tube fertilization of angiosperm plant, and till then no one thought that flowering plant could be fertilized. Very first time he did the cross breeding for many flowering plant. He has cultured the embryo also. So his work was primarily on the test tube fertilization and intra-ovarian pollination. So, and he got the Padam Shri for his contribution in the science. Another scientist is Janki Amal. So Janki Amal was born in Tellicherry, Kerala. She was another famous botanist. She has contributed immensely to the plant breeding and the cytogenetics, and she also categorized and cataloged various medicinal plant. And in Coimbatore, there is an institute on sugarcane. She was a founding director of that institute, and she has created many breed of sugarcane and the eggplant. She got the Padam Shri for her contribution. The Homi Jahangir Bhabha. So he was a nuclear physicist who has contributed to the quantum theory and the cosmic radiation. He is considered as a father of Indian nuclear program, and his idea was to generate electricity through nuclear energy, and he was opponent of making nuclear bomb using nuclear energy. So his idea was very constructive. He wanted to use nuclear science for the benefit of the society. Yes, he was the founding director of the TIFR, and later the one institute which work on nuclear physics called BARC was named after Homi Jahangir Bhabha. So BARC is the Bhabha Atomic Research Center, and he died in a plane crash. And later it was, it was a kind of suspicious death, because during his time, India was growing like anything in the nuclear program. So suddenly he died, and it was came in the news that he died in the plane crash, but still it is considered as a conspiracy theory. So the another scientist was Vikram Sarabhai. So Vikram Sarabhai was born in Ahmedabad, and he is considered as a father of Indian space program. In Bangalore, with Professor C.V. Raman, he started setting up various observatory in Bangalore, Pune, and the Himalaya. And his real work began in 1947 along with meteorologist K.R. Ramanathan, and he has established a physical research laboratory. So now you can see that our scientists are capable of predicting the weather well in advance. But this work was actually initiated by Vikram Sarabhai. So Vikram Sarabhai has established the Indian Space Research Organization, ISRO, which has contributed significantly to the Indian space program. And he set up India's first rocket land launching station in the Thumba. And the reason why they set up the first launching station in the Thumba, because the magnetic force, Earth magnetic force was very less in this particular reason. He got the Padam Bhushan in 1966. And Satish Dhawan. So Satish Dhawan was an aerospace engineer, and he was the third chairman of ISRO. He is considered as a father of experimental fluid dynamics, and his contribution was SLB, PSLV, and the remote sensing. So now the satellite launch center in Sriharikota was named after Satish Dhawan. So they are very famous. If you read the biography of Dr. Abdul Kalam, you will realize the contribution of Satish Dhawan not only in the science but as a leader, as a team builder. So when Dr. Kalam was working on one satellite and when its launch was failed, instead of allowing Kalam to face the press, he was the first person who faced the media and said, "It is my responsibility, and I have full faith in my team, and I'm sure that they will get success." And after that, that launch of that satellite was successful. So Kalam considered Satish Dhawan as his mentor. And you can see the evolution of ISRO, how ISRO was evolved. In initial year, they were carrying their rocket on the bullock cart, on the cycle. And now you can see recently that Mission Mars was successful. And then there was a movie which was recently, made by the Bollywood, Mission Mangal. So where they have elegantly described the contribution of ISRO. And of course, they have also depicted the teamwork. So now, Dr. Abdul Kalam, you know that Abdul Kalam is known as the Missile Man of the India. He worked for DRDO, which is the Defense Organization, and the ISRO. And he worked with Sarabhai that I just told you. And he was the pioneering in making missile, and he also contributed In the launch of SLV3, he got the Bharat Ratna, and he was also the 11th president of Indian Republic. And another scientist is CNR Rao. So CNR Rao is another scientist who got the Bharat Ratna. He is highly accomplished chemist and the material scientist. His contribution in the solid state and material chemistry is massive, and he is the most cited Indian author till date. And he has contributed to transition metal oxide, carbon nanotube, and he is also considered as a father of nanotechnology in India. He got the Bharat Ratna. And Dr. Bhan. So Dr. Bhan is a very accomplished clinician scientist who has contributed towards the development of indigenous rotavirus vaccine. So up till now we talk about the science, but this person not only contributed towards the in science, but also contributed massively in the capacity building. He was a DBT secretary, and he has established BIREC and various biotech science cluster across country and various incubator center. And this institute, THSTI, was also the brainchild of this person. So BIREC is a funding agency which has created a paradigm shift by giving funding to various startup. And he was awarded with Padma Shri and Padma Vibhushan, and he has recently died. So in the last, I will tell you a small story, the story of a mice and a mountain. So, there was a mice and who lived in a mountain. He was having a hole, which was his home in the mountain. So that mice one day think that, who is the most powerful person. So he looked at in the sky and found that sun was there. So he thought, I should go to sun, and he went there and asked him that I want to marry your daughter. He said, why? Because I think you are the most mightiest and most powerful. He said that no, I am not the powerful. You should go to the cloud, because cloud can cover me. So he then went to the cloud and said, I want to marry your daughter. So cloud said, why? He said, because I think you are the most mightiest, most powerful. Cloud said, I am not the most powerful. You can go to the wind, because wind can blow me away. He went to the wind and said the same thing, that I want to marry your daughter because you are the most powerful, most mightiest. The wind said, I am not the most powerful, most mightiest, because I cannot cross the mountain. Mountain can block my path. He went to the mountain and said that I want to marry your daughter. Mountain said, why? Because you are the most strongest. The mountain said that I am not the strongest. Even a small rat can make hole in me to create his home. So you should marry a mice. So why I told, then mice realize its own power. So why I told you this story, because every time we look at others, we look at US and other country, that their contribution and the level of science. So if we realize our own potential and contribute in science, we have the same level of intellect, we have the same potential. Only thing is we need to unleash our potential so that we can contribute to the science. And if you see that our forefather and our ancestor has contributed this much to the science, they've already created a footprint that we need to follow. So with this, I want to end my talk, and I want to thank to our forefather who have contributed to the science immensely and left footprint to follow. With this, thank you so much.
Thank you, Dr. Tarun, for a very wonderful talk. He's talked very briefly about all the ancestors, especially the scientists which we have had, and also about the recent scientific developments. And he's mentioned a lot of scientists and a very beautiful story also. So I would, in fact, ask all of you to look into yourself and do encourage. And as I've told you in the beginning, don't stop learning, keep learning. Moving on to our next talk, it is from Dr. Neeraj Kumar. It is about the role of science in the COVID era. Over to you, Dr.
Thanks, Suma. So, okay, so as Suma told, I will be talking about role of science in COVID era. So, if we say, okay, there may be the impact of the COVID as well on the science. So, both way, it's very important for us to know about it. Okay, so in the first talk, I will be talking about impact of science on COVID. So as you all know already that by 8 December there was the first case of the COVID in Wuhan in China. Okay, so if we want to see the strength of the science, the role of the science was started on the day when the first patient of the COVID was detected, because you cannot say whether this disease, whatever they were calling it, a typical pneumonia, whether it is due to the environmental pollution, or it was because of the bacteria, or it was from because of the virus. So when you get to know that this is first of all is a pneumonia case, a typical pneumonia case, means that means the science has already started playing its work. Okay, so then later on 31st December, China reported 27 another cases. Okay, so when you are saying 27 other another cases, means again science have played role in detecting other cases as well, because unless you have a method or the science to detect whether this is a pneumonia or the COVID case or the similar case, you cannot say this is again another case. Then 7th January, disease was called as a novel coronavirus 2019. So now the question is again like how they called it corona, why not something other something else? So here again the science was important key player for naming this virus. Okay, and then 13th January the first case was reported outside of the China. So when uh, this was in the Chinese scientists in the China were playing the key role, but now the scientists in another place also get involved, and the science started playing its role at the global level. And later on 11th February, disease was named as COVID-19, and the virus was named as SARS-CoV-2. So they said it's SARS-CoV-2 because there was already a science behind giving the information about SARS-CoV-1. That's why they were able to say, okay, this is SARS-CoV-2, this is different from the previous one. So, and later on by 11 March, WHO declared is the COVID pandemic. Okay, so now if we want to see, okay, this was a zoonotic disease. So now most of the new emerging diseases of these 70% are the genetic origin, and later on it was declared as a growing public health threat for the system. So if you want to see, okay, you want to manage the COVID pandemic. So here again, that science was very critical, because if you don't have scientific approaches, it's hard to control any pandemic. By now we know that this disease is because of the SARS-CoV-2. We got to know that the primary host was probably the bat, and it was infecting the human as well. But now the question was, okay, if one human got the disease, how the others are getting? So then by March, scientists were able to decode that this disease is transmitting through the air droplets, or there are multiple modes that because of which this disease is actually moving from one person to another. So then now the next question was, okay, if we got the disease, how we can control it? Then again science came into the picture, and they started giving the theories, giving the evidences, okay, how we can control. So like quarantine. Okay, so you can quarantine, you can give the therapeutics, you can give the vaccines, or you need some diagnostics as well. So these four pillars played major role in managing this COVID pandemic, and again these all are contributed majorly from the scientists and the clinicians. So by now, people say the most effective tool for managing the COVID pandemic is isolation and quarantine. But when we say isolation and quarantine, first of all, you need to diagnose them so that you can do this. You can apply this tool for this. So for diagnosing this, again, there were two things. Like if the patient is or the subject is symptomatic, you can diagnose, okay, this is having cough or fever or something like that. You can simply say, okay, this person might be having the COVID-19. But again, there were cases which were asymptomatic. And again, there were people who had the early stage infection or through the contacts. So for those kind of people, you were actually needing the diagnostics. And there was a country level approach for the lockdown as well. So like if you want to control the transmission of this disease from one location to another location, the governments utilize this lockdown approach. Okay, so but lockdown approach was also devised by the scientists in the previous years with the previous pandemics. So based on that, they were actually able to say, okay, lockdown may be the one of the recipe to control this disease. So now we want to see the another role of the science. First of all, when we got to know that this disease is spreading from one person to the another person, so there was some need of equipments that can help the clinicians or the front workers to get infected from these diseases. So there the role comes for the personal protective equipment. So initially, when the COVID started, we had very low manufacturing capacity in India for these PPE kits. But again, over time, in a very short period of time, India did substantially good. And within 6 months, the India became the second largest producer of manufacturing these PPE kits. And at the moment, India have more than 7,000 crore worth industry for PPEs, and there are approx 1,100 manufacturers in this domain, and we can produce approx 5 lakhs PPE kits per day. That is a huge amount. Then another thing was like sanitizers. So we know that the bacteria, the virus is spreading now. It can sustain on the surfaces. It can contaminate from one by touch or contact to another person. So you need something so that if you have by chance contacted any surface, you want to sanitize that. So there was a need of the sanitizers as well. So if you see the Indian industry, it was approx in 20, it was approx 400 million USD dollars. And by 2025, it is expected to grow by 2 billion USD dollars. So when you talk about sanitizers, there may be different products based on the consumers. You need to design your products. So like it could be a gel, it could be a liquid, foam, others, and formulations. There was some alcohol-based, alcohol-free, herbal, UV-based sanitizers. And again, there was need for the end users, a specific manner. Hospitals need something different than what restaurants and hotels need, and the household needs differently than the what vehicle or the baggage cleaners need. So something like that. So but this all was available during the COVID pandemic, and this was again just because of the scientists who were working constantly throughout the day, throughout the month, throughout the year for developing those solutions for our natives. So when we talk about the diagnostics, again, when we talk about the diagnostic, there may be different kind of diagnostics. Okay, so first of all, it could be based on the samples. So what samples you want to use is either nasopharyngeal swab. This is one of the most commonly used sample at the moment with the current diagnostic. Could be saliva or could be the blood. Okay, and when you are talking about these samples, then again the issue is like antigen. You want to detect the antigen. If you're talking about the antigen, there could be again two things, two biomolecules. It could be RNA based or it could be the protein based. So based on RNA, RT-LAMP, RT-PCR, CRISPR-Cas, these technologies were developed worldwide. And in this domain as well, India has also done significantly. If you see in the first last column of the table, so India has done significantly. Then you could be interested for having a protein-based protein detection there. Lateral flows were there. ELISA-based kit were there. And once you want to see whether any person has already been infected with this COVID previously or not, do you want to check the antibodies? So serological studies kind of thing. So for that, lateral flow and ELISA were also there, and India has also contributed into that. So later on, you could also consider whole body scans where you can use X-ray imaging just to see whether how the treatment is working with the patient. So again, when we talk about these diagnostics were developed very rapidly. In the first month of the infection first report in January, the first diagnostic was developed with by the CDC. Okay, that was again RT-PCR based, but again, like the scientist has really contributed significantly so that they were able to develop that first primers for against this SARS-CoV-2 virus. Okay, so once they developed that, then only it is spread to the other part of the globe as well, and it was utilized later on in the whole world. So if we talk about specifically about India, so India, of course, the government has been playing a key role in developing diagnostics and supporting the manufacturing system in India. So like ICMR has significantly contributed, Department of Biotechnology and the CSIR also. Their network has significantly contributed in this domain. So if we talk about the educational institute level, so National Institute of Pune was the first institute that helped my lab to develop their RT-PCR based diagnostic assay. Then THSTI, Translational Health Sciences and Technology Institute, they developed their antibody detection based system that is also commercialized at the moment. And ICGB contributed in the same line. And then Institute of Genomics and Integrative Biology, they also developed one diagnostic called Feluda that is being at the moment commercialized by the Tata MD. And as I said, like my lab, MDI, Cyton, Zydus, they were the industrial player which worked together with these institutions and the regulatory bodies just to bring these products into the market as earliest as possible to save the country from this pandemic. So when we talk about the therapeutics again, so there were number of drugs already being used as an antiviral in the country previously. So now the question was like, if you talk about the therapeutic, you cannot develop a therapeutic within 1 or 2 months. So the best bet with the scientist or the clinician was just to repurpose the drug. So in that direction, the world started using different drugs that were already in the market, were FDA approved and were being utilized for treating different kind of viral infections. So many have been tried in the global level as well as in India. So like besides allopathic drugs, India has also investigated the role of the herbal products to control this COVID pandemic. Like the Ayush Ministry has tried ashwagandha, gucci, and Chyawanprash to see if it can help us to get relief from this COVID-19. And again, like the Patanjali has also explored, like if the coronil can help us to treat with this disease. So when we talk about this, the key players, again, the government itself, the ICMR, DBT, CSR, and Ministry of Ayush, they have been the key players. They have been the key funders. They have been the key regulators for letting the people develop, or the scientists develop the drugs or potential drugs for the purpose. So CDRI as academic institute has contributed significantly into that, along with the THSTI and ILS. So now if we move to the vaccine section, so again, there are at the moment number of vaccines available in the market. So this is the graph showing, this is the graph map showing the different kind of vaccines available in the world. So like we already all know that the Moderna is being used in US, another vaccine is being in, some vaccine is being used in UK, Sputnik is being used in the Russia. So India has been using Covaxin at the moment, and the Covishield, and both the products have been developed indigenously in India itself. So like the Bharat Biotech has developed its own vaccine, even the candidate, with the help of NIV Pune and ICMR. And Covishield is developed with the AstraZeneca, and that is also at the moment clinical trial phase 3. So if you talk about the who have been the key player for this, like the ICMR, again, Department of Biotechnology, and CSR, they all have been the instrumental in facilitating this development of these vaccines candidates here. So Bharat Biotech, Serum Institute of India have been the major industrial, I would say, the developers for these vaccines. And National Institute of Pune, again, like and THSTI has also contributed significantly into this domain. So when we want to talk, we want to conclude things. So we can see from these slides, like we were very successful. We were very successful in developing self-sufficiency in production of different PPEs, sanitizers, thermal scanners, and other equipments required for handling this COVID pandemic. And at the same time, we were very well versed in developing novel diagnostics, vaccine, and therapeutics for Indian need. And that too was to happen in a very small period of time. So this altogether show that we have appropriate ecosystem available for innovation. And based on this ecosystem, we can really develop new products, and we are ready to fight with any such healthcare threat if any happens in the future. So basically, we have the capacity, we have the capability. The only thing is we have to have the intent as well to do this. That's all from my side. Thank you.
Thank you, Dr. Neeraj. A very informative and valuable talk, where you talked about the way India has responded to this COVID situation. We all call it as COVID era. The importance of make in India, made in India. He's talked about the PP kits that India has manufactured itself, the swabs, the sanitizers. And I'm very happy and proud to share with you that THSTI and the other institutes of DBT, CSI, and other institutes of our country also have contributed immensely towards this COVID scenario in tackling this, and not to forget the Ayurvedic interventions. Thank you so much, Dr. Neeraj. And I'll request all of you, we'll take a 5 minutes, very short break. We'll all come back after 5 minutes break. And one more, I will request all the participants to be ready with their question answers. We will be having a question answer session. We'll have a second session, after which we will be having a virtual lab tour, which will showcase the various facilities which we have at THSTI, and then we'll have the question answer session. So we'll take a short break, and we'll come back exactly after 5 minutes. Welcome back. So we are back with our session. Now we have a talk by Dr. Shushmita Chaudhary. She will be talking about the various opportunities for the youngsters at THSTI. Over to you, Dr. Shushmita.
Thank you, Soma. I hope everybody is back after the break. We'll start anyway. Piyush. नीचे ऊपर 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 सेकंड वाला Okay, so in the last session, what we have gone through is we were trying to inspire you and convince you people about the impact of science and the impact of science in the whole world, in our global economy as well as in India, and how India has contributed towards the advancement of science in the global perspective. So now this session is all about what THSTI is doing in that whole scenario, how THSTI contributes in that entire ecosystem of science and innovation, specifically innovation, because to align with the theme, the current theme of our National Science Day, and what all resources we have, what all has already been done, what we have achieved till date, what we are thriving to achieve. And this whole session with 3-4 talks will cover that. So what I will start with is I'll give you I'll walk you through a few processes at HSTI, which basically shows you the opportunities for all the students, all science stream students, to come and work in THSTI and get involved in the workforce. So I'll just keep in mind that these opportunities are same for all the domains that we will talk about in the next 1 hour. So so all these are available on our website. Please visit our website and look at all the research domains of all the principal investigators, all the faculty and scientists. So I'll just briefly touch about what are the main domains of research in India. So in the infection and immunology or infectious disease research area, a lot of faculty work on TB. There are groups working on HIV, hepatitis E virus, dengue, SARS-CoV-2, influenza, and also other viruses like respiratory syncytial virus and Japanese encephalitis virus, and so on and so forth. Broadly, disease biology, pathophysiology, molecular biology, genetics are the areas among these diseases which are the focus of these labs. So then we have a very big group, which is a clinical research group working on maternal and child health. And they work on the pregnancy outcomes affected by lifestyle, infection, and environment. There's a huge cohort on pregnancy going on, and based on that, a lot of studies are planned. They also work on neonatal nutrition, neonatal immunity, and aspects of developmental muscle and other systems. So there's a big non-communicable disease group, which is majorly a drug discovery group, and they work on non-alcoholic fatty liver diseases, diabetes, and etc. And also there is a group on different multidisciplinary research, clinical and translational research. Then this group specifically focus on developing products or product innovation, which are in the domain of diagnostics, in drug delivery formulations, in devices, and in therapeutic antibodies. So having said that, there are a lot of programs which are cross-disciplinary, which touches upon different domains in this entire list. And also, we are always open for any new ideas and any new domains to start. And since last year, SARS-CoV-2 has become almost the major domain, the biggest domain of research by all the faculties in THSTI.
So the first program that I'll talk about, where all of you can join, is a short-term training program at THSTI. The short-term training program has different levels of students that we take. Specifically, this is for bachelor's and master's students in life sciences, pharmaceutical sciences, chemistry, mathematics, where for completion of your thesis, a dissertation has to be done. So for this, you can do that thesis, that dissertation at any research laboratory of THSTI. So usually it is an in-house training period of 4 to 6 months for master students and 2 to 6 months for a bachelor thesis. So any student who has any specific fellowship from any government agency or any academic society can also undergo a short-term training for 8 weeks to 6 months. For getting into these training programs, what you must be having is that you must be from either from UGC recognized public university or from UGC recognized private university. You have to have a consistent first class marks from class 12th onwards. And these are the fields life sciences and engineering and pharmacy are usually and also veterinary are usually the fields that we take students from. The applications for short-term training program are accepted throughout the year. You can directly email your application to academics at THSTI, and with mentioning the supervisor of interest that which lab you want to come to with your updated CV. It also should be accompanied with a recommendation letter from the head of the institute or head of the department of your degree granting college. And after the application goes through a review process in the THSTI academics department, then the acceptance is usually communicated to the student. So a minimum of 4 months of training or lab work is mandatory at THSTI in any of the THSTI labs to get a certificate out of this, so that you can complete your dissertation, so that you can complete your degree. Next, what I'll mention is the PhD program at THSTI. So the PhD program is for the entire institute. So all the faculty and scientists, most of the faculty and scientists are a part of this PhD program. You can choose any lab, and then based on matching of the student's choice as well as the PI's choice, the labs are designated to each student. So mostly the PhDs are on translational research, mostly on innovation research at HSTI. That is what makes us apart from the rest of the lot. THSTI is recognized by JNU. So for all the the degrees for the PhD come from JNU, is given by JNU for doctoral program in biomedical research. For admission in the PhD program, the students have to undergo or qualify in any of the national level scholarship exams. So they should have their own scholarship, or they should qualify the GATE exam or any other exam when they do not have, for that particular subject, when they do not have any CSR or UGC NATE. Once the students are admitted, so there is a written exam for people who do not have their own fellowship, and there is an interview program for process for all the students for the final selection. Once the students are admitted to the program, they have to undergo a coursework, which is mandatory, and then they are designated to a lab in THSTI. And after the completion of the thesis of research work, they have to submit a thesis for review, external review by the university, which is JNU in our case, and then go through a Viva Voce exam to get their degree. So this until now was this was like all the conventional programs or conventional opportunities that you get in other places also, but ours is a little bit different because ours are mostly on translational research. The other thing which sets us apart is an innovation fellowship that we have at our institute, which are mostly by design innovation fellowships. So this is targeted for students with interest in product development and entrepreneurship. The other stuff is mostly knowledge driven. This was an innovation driven. For this one, we accept professional bachelors, which are BTech, BPharm, professional masters, MTech and all, and general master's level students. And you have to go through a selection process. The selection process is quite rigorous. So once they are admitted, these are very short-term fellowship, like 1 year or 2 years. And once they are get admitted, then we train them. Initially, we train them in market research and unmet need finding and prototype development, prototype testing, and business plan development and everything. So we train them for a few months, and then they go into immersion in the society, in field trips. They go into immersion in clinics, in our clinical sites, and then they do a complete completely independent need finding, need filtration, and solution development to an unmet need for to develop a product. And once they have developed a viable product, it goes through a very rigorous review by an expert panel. That expert panel includes not only faculty from our institute, it also includes interdisciplinary faculty from IIT, from Chennai IIT, from PGI Chandigarh, and from SIMS Vellore, from IIT Delhi, and also business people and investors from venture centers. So once a solution is found viable, then we definitely we encourage those candidates or those students to go for further development of that product, and we help them get seed funding and help them establish their own startups. So this is a very interesting program that we have, which is kind of one of a kind for people who are very proactive, self-driven, and are inclined towards entrepreneurship while working in research. So apart from this, we also have a lot of hands-on training programs throughout the year. And these are on different high-end platforms that we have. There is next-gen sequencing, it is mass spec, RT-PCR-based diagnostics, imaging, NMR, liquid handling automation, and so on and so forth. I'm just mentioning a few of them here. These lists, whenever the high-end hands-on trainings are planned, it is advertised on our website, and you can always join online, I mean, apply online for this. And this is all. I hope you will find at least some of these useful and suitable for you to get involved in the THSTI community. And in the next few talks, people will talk about, or faculty will talk about what all are being done at THSTI, and we'll also show you a lab tour so that you can decide how you want to join THSTI.
Thank you so much, Dr. Shushmita, for that very important and informative talk. So she talked about the very short-term trainings which we have, which is for the undergrads as well as for the PG students from various disciplines. So they can actually look into that. We also have a dedicated PhD program. Kindly go through those things. And she did talk about the Innovation Fellowship, which is one of its kind. So do look into that aspect also. And keep looking at the website where we do advertise about a hands-on training on the various platforms which we have. So very informative. Thank you, Shushmita, for that talk. Now the next talk is again very interesting because it talks about the product development and the entrepreneurship which has been taking place at THSTI. For this, I would request Dr. Neeraj, Dr. Tarun, and Dr. Chandresh to tell you briefly about what has been going on at THSTI. Over to you guys.
So, good afternoon, everyone. I am Chandresh, and I will be initiating the session, and followed by Tarun and Dr. Neeraj. So, So as I was telling that I will be quickly walking through product development at THSTI, and entrepreneurship will be taken care by Dr. Neeraj and Dr. Tarun. So I will quickly start with the biotechnology product innovation for healthcare at THSTI. And we should first start with the definition of innovation. What is innovation? So innovation is the creation, development, and implementation of new product, process, or services with aim of improving efficiency and effectiveness or competitive advantage. In a simple terms, innovation is a translation of your ideas for which you can be get paid off by the end user. And for health sector, there are four types of innovations, which are predominantly incremental innovation, which is kind of existing innovation, and later on phases there is always a modification and increment on this. This is majorly in the industries. Pharma industries does that for refining their products. Other one is disruptive innovation, which actually kills the initial innovation and comes in a different package. The example for this would be 3D printing or nanotechnologies. Other one is architectural innovation, which actually is innovation. It's also comes in new uh, like new innovation from the existing innovation. It's like opening a facility or center, and radical innovation is totally new kind of innovation. uh, Example can be a new kind of vaccine, new kind of drug, or something like that. So how innovation takes? Before innovation, we need to think about, we need to do a landscaping, and we need to do filtration for how, what to innovate, how to decide our innovation. So I will be quickly going through the overall process for that. So there are different stages of product innovation. Initial is identify. This includes focus area, in which area we should innovate. We need to find the needs. We need to screen our needs, what actually population needs. We need to identify. Next is invent. Invention includes concept generation, concept selections, and final is implementation. We develop strategies and planning and integrate them all to reach to the goal. So what are the focus, what should be the focus area for like doing innovation? So you can see there are 4 Ds: discovery, design, develop, deploy, and impact. To make a very good impact, we focus on design, develop, and deploy. Discovery is also taken care in THSTI, but we focus majorly on design, develop, and deploy for product innovation. And we can see in the lower panel, we target early diagnosis, and uh, on the basis of early diagnosis, we design a target treatment and see the outcomes to maximize the effect. So here I show overview of process. Here we can see in blue dots the needs. So there are several needs, and from out of that need, according to like innovation, specific innovations are filtered. We generate concept, and the final concept is taken care uh, and taken forward to implement of a product innovation. So while developing this thing, product, we focus on the areas for consideration to develop a target product. We focus on how the project is going to fit for, and how it's going to affect the health outcomes, how much time is going to require, and what are the resources we are going to use. how it will reach to customers, what actually customer needs that, what revenue will be generated, and what are the market areas, and what are the market dynamics, like who are the competitors, and based on these acceptance criteria as well as different other criteria, a target product profile is being defined. So I just wanted to also pin on the point, how do innovators fail? So there are many reasons, but one reason may be they don't identify the unmet need. Second, they fail to they fail to meet customer requirements, as well as they pitch in incorrect pricing for their products, and it's not cost effective, so it can't be used again. So suppose that if the invention is like required at some moment, and if it comes later on, so it's of no use. So this is also a criteria for failing innovators. There are also repositories are not available, and there is no unique selling points, and the market forecast is incorrect. So these may be a specific this thing, failures for the innovators. So coming to prototype, what is prototype? And I said that target product profile is defined, and later stage is prototype developing. So prototype is nothing like a picture. As you see, a good picture on the Facebook or anywhere gives 1,000 words. Like that, in medtech innovation, our prototype is worth of 1,000 pictures. So basically, if we define prototype, prototype is a simulation or sample version of final product, which is used for testing prior to launch. And here we can see a diagram where prototype is being developed, reviewed, and refined in an iterative manner. So what can be prototype? So before getting into what can be prototype, I should be telling that prototype takes a design process, which starts from understanding and observing how the prototype should be developed, visualizing, evaluate prototype, and then implement. And these all are in like iterative manner. And there are 3 different stages of prototype: inspire, evolve, and validate. And coming to again now types of prototype. The prototype can be sketches, diagrams or frameworks, handmade constructions, machine constructions, virtual models, graphics, packaging, spaces, role play can also serve as a prototype. And some of the videos can also be, there may be many other ways of representing the prototype. So what are the uses of prototypes? So prototypes can actually tell us what is the better design. When we make a prototype, we come to evolving ourselves to pitching what is the best design for the prototype. Actually, it tells clarify the goals and requirements. It reflects the conversation with the material, what material should be used, gives user experience of use, and test specific aspects. Like it can compare between the different models, make changes and all, and also shows the feasibility for buying in. This includes proof of concept and manage expectations of end users. And last not but the least, a prototype can tell whether we can invest money behind that prototype or not. So in the right panel, I have shown the graph between cost versus project timeline. And it says that if you fail early, then you are going to save lots of money during a project. You save lots of money as well as lots of time during the prototype development. And if you fail at too late stages, you lose lots of money. So coming to the THSTI pipeline, what we do. So I'm going to walk through the pipeline of product innovation in THSTI in 2-3 slides. So here I show biomarker discovery. We do genomics, which analyze changes of occurring at the gene level. We do proteomics, analyzes changes on the protein level, and also metabolomics, which analyze the differences in chemicals, molecules that play an important role in body and cell function. And we come up with a biomarker, which is used for our inventions. So for that, we express designer protein. We create drugs against the biomarkers. We generate monoclonal antibody, and we generate vaccine. And we also generate diagnostic binders such as monoclonal antibodies and aptamers. We also do some devices. We make devices. And in this slide, I'm trying to pitch in for the example, how the assay is being developed for our, how the point of care testing is developed. So here we can see a lateral flow assay. So there are different stages of developing a lateral flow immunoassay, and you can see I have labeled 10 of them, like nanoparticle, antibody, membrane conjugate, and many more things are associated with lateral flow immunoassay development, and all are interlinked with assay optimization. Suppose that for nanoparticle, what kind of gold nanoparticles are being used, what kind of antibodies we are going to use for test line, detector antibody, and control line, what material for membrane is being used, what material for conjugation is. All these need to take care while developing an assay. So, and the end of next step, like end of product development, is evaluation or validation. It may be clinical validation and data analysis due to post-clinical validation. So in a nutshell, translation research or innovation is from bench to bedside to product, and again to bench in an iterative manner. So this is my last slide, and I would like to tell what are the product developed at THSTI. We can see there are like some of the product like snake bite and SARS-CoV-2 vaccine at proof of concept level. Tropical fever diagnostic is reached to pilot level. And first successful product for THSTI was celiac disease diagnostic kit. TB diagnostic has also reached to clinical validation. Blood safety is also to clinical validation. And in response to this pandemic, there were two SARS-CoV-2 diagnostic kits. One was antibody detection and other was antigen detection, which has reached to clinical validation phase. And this has been licensed from THSTI. And we are also developing diagnosis for AMR. Thank you.
Thank you, Dr. Chandresh, for that very valuable insights. And so he talked briefly about why do innovations fail, the role of prototype and POCs and various omics that is being carried out at THSTI. He's also given a very brief idea about the products that are being developed in THSTI. We'll have next talk, which is again a part of this product development and entrepreneurship by Dr. Tarun Sharma.
Anyway. All right. So first we'll talk about what exactly an entrepreneur are. So this term was coined by Richard Cantillon, who was a French economist. So the word entrepreneur or entrepreneur actually itself tells about the risk bearing capacity. So the literal meaning of entrepreneur is the one who has ability to take risk. So if we define entrepreneur in a very simple way, so an entrepreneur is a person who sets up a business or businesses taking a financial risk in the hope of a profit. So, and what exactly the innovation is. So you can see in the society that some persons are born innovative or creative, and some can be innovative in the later part of their life. So innovation is a discipline that can be learned. It's a process of translating an idea or invention into a good or service that can create some value for which customer will pay. So there are two type of innovation. One is the product innovation and other is the process innovation. So process or service innovation, you can say. So product is something that you buy and services that you avail and pay for it if it is valuable for you. So in the next slide, I'll be talking about the various type of innovation. So although broadly the innovation can be categorized as a product and service or product and process, but technically speaking, it can be of 9 different types. So let's begin with the service innovation. So service innovation is one that is if you introduce something new or significantly improved service that generate new customer value. So if I give you some example, one good example could be the courier service, TTDC or any other courier service. So previously you see that speed post was there, which was taking around 3 days to deliver your any parcel to your doorstep. Nowadays you have variety of courier service that can deliver any package from your office or your home to the intended customer in a day or two. So it is a very good example of service innovation. And the other type of innovation is a business model. So business model is basically you are changing the way you are doing the business. The customer was already there in the market, the product was already there in the market, you are changing just the way you need to deliver your product and services. So one good example of business model is Zomato or Swiggy. So hotels was already there and food demand was there, only thing is they are delivering food to doorstep. So that is another type of innovation. Then comes the disruptive innovation. So disruptive innovation is something that displace established company or industries. So one good example for disruptive innovation is, Android mobile phone. Earlier you were having the Nokia. So that was non-Android device. But when the Android enters in the market, it has disrupted the keypad based phone completely. And then comes the other innovation. So then we have the breakthrough innovation. So breakthrough innovation is the one that happens in once in a century or maybe in 100 and 200 years ago. So the breakthrough innovation, if I give you example from the medical point of view, the chest x-ray or x-ray machine is basically the example of breakthrough innovation. And from microbiology point of view, you can consider gram staining as a breakthrough innovation, because even though the gram staining was invented long back, still we do not have any technology that can outperform gram staining. So these kind of innovations are breakthrough innovation. Then you have organization level innovation, where the innovation in a way that so that people can manage and share resources. So if any, because some of the students are from the Maitri College, which are in Delhi. So if you go and visit the Rashtrapati Bhavan, you will find a bike called Yulu. So this Yulu bike is based on the sharing model. You pay at the metro station, hire that bike, use it, and then again leave it at any place, their person will come and collect it, and the same cycle will be used by other visitor. Then there is an innovation called in outcome driven innovation. So in outcome driven innovation, you already know that what sort of outcome you are intended for. So example for this is Tata Nano. So Ratan Tata already know that they want to design a car for a small family, and this car should be cheap so that middle class people can afford it easily. Then we have the incremental innovation. So incremental innovation is a small continuous improvement to to existing product, services, and the process. So you can see this as an incremental innovation. Earlier we were having the electricity bulb, then we have the CFL, now we have the LED TV. So over the period of time we have seen this kind of innovation. Then we have the product innovation. So product innovation is the introduction of new or significantly improved product that can create or generate customer value for that customer can pay. So example for this is blood glucometer. So this is a very good innovation that has changed the life of millions of diabetic patients. With this, they can now regularly monitor their blood sugar levels to manage their diabetes. Then we have the process innovations. So process innovation is an implementation of a new and significantly improved production or delivery method. So if I give you example from the medical side, you can see the SRL lab or the Lal Path lab. Earlier, you need to go to the diagnostic lab, and then their technician will withdraw the blood and they will test it and send the report back to you. But nowadays they have changed the process. They can send their person at your home. He or she can draw the blood, and then they will take this blood to their diagnostic lab. They will analyze it and send the data to you or report to you by email. So they have changed the entire process. So this we call the process innovation. Now there is another type of innovation that we call frugal innovation. So frugal innovation is something to extract maximum from the minimum. Or so you can see some of the example. This the jugaad that we commonly call. This is also an innovation. We called it jugaad innovation. Then you have this Mitti Cool fridge that was developed by Mansukh Prajapati from Gujarat. He has created this refrigerator which runs without electricity, and it can keep your vegetable and fruit fresh for 3-4 days. Then you have then we'll talk about the innovator and survivor. So innovator is a person who actually quite imaginative, who can think of future disruptive projection. On the other hand, the people that we call survivor, they do business on their experiences. So they are primarily rely upon the existing old assumption. So innovator can innovate things for the benefit of mankind through their imaginative capabilities. Then you can see here, all these are innovations. So basically we are innovating the innovation. We are innovating the innovation. So development of telephone itself is a big innovation, but over the period of time, you can see there is a paradigm shift. Earlier we were having the dialer phone, then we have the keypad based phone, now we have Android, and now we have phone which has a very good quality camera. And this is another type of innovation. You can see here the variety of television. In 1930 you have a very small black and white TV, and in 2020 you have a OLED TV which with a HD quality. So we can innovate innovation also over the period of time. Now we'll talk about the need driven innovation. So you usually innovate when there is a need. So when you have a need, you identify the need, and Dr. Chandres has already explained how to identify a need. So through need identification, then by generating various concept and then selection of the concept, you can pick just one concept to address that need. So through that need, you can get the lead, and then you can generate the idea pipeline. Then you need to do the pilot experiment. So pilot experiment, why we do? Because we can make a small mistake and then we can improve upon it before the product launch. So this is the whole process of innovation. First you need to identify the problem, then you need to plan for it, then you need to create a prototype, then you need to review the prototype whether it is working fine or not. So the product development is a continuous improvement cycle. You need to improvise based on the feedback of your customer or the end user. Now we'll talk about the idea. So we can get multiple idea, but how to choose the best idea? So there could be sellable versus passionate idea. There could be something that you are passionate about it, but not necessarily it will be able to generate revenue, and you cannot scale it. So your idea should be sellable, someone can buy it. And if you cannot make money from your idea, then it is worthless. Then your idea could be very innovative, but it cannot solve the existing. If it cannot solve the existing problem, no one will be interested in your idea. If your idea is problem solving, even if it is a simple idea, it will be having a huge market. Then you can choose your idea based on the market size. For example, if you want to develop some diagnostic assay for a rare genetic disease where your market size is very less, maybe 1 out of 10 lakh people have that disease, so your market size will be very less. You will be able to generate very less revenue. On the other end, if you target some disease like TB or typhoid, your market size will be very big. So based on this parameter also, you could select your idea. Then you can work on one idea at a time, or you can work on multiple idea. It's up to you whether you have that much capacity, whether your team has that much strength to work on multiple idea parallelly. If your team is small, then you should work on one idea at a time. Then in order to translate your idea into the product or service, it is good to have your startup. So when you start or venture into a startup, you can go alone, or you could be a solo entrepreneur, or you can have a team of co-founders which are having the complementary expertise. So choice depends on you. So this is the one example of innovation from our group. This is my last slide. Basically, you can see here that this work we did in collaboration with Professor Jaya Tyagi at AIMS. So her lab in 2009 first time showed that we could detect TB meningitis through CSF. Later on, we developed antibody-based assay, but we were facing batch-to-batch variation. So the reproducibility of that assay was not very good. So later on, we developed aptamers because our expertise is aptamers. So aptamers are synthetic single-stranded DNA or RNA molecule that can fold into a two-dimensional and three-dimensional shape to bind its target with a high affinity and specificity. So we developed aptamers against the TB antigen, and we developed two assays. One we called ELISA, aptamer linked immobilized sorbent assay, and other is electrochemical sensor in 2018. So this is how innovation take time to get a proper shape. So with this, I will rest my case. Thank you. And I would like to acknowledge my team member and my mentors.
Thank you, Dr. Tarun. He's talked about the various types of innovations, the breakthrough innovations. I was actually very impressed with the frugal innovations that he cited, about the mitti cooler and the jugaad that we actually do, and very aptly talking about the examples from our daily life. Moving on to Dr. Neeraj, he would also be talking about the product development and entrepreneurship. Dr. Neeraj.
Thanks, Tarun and Soma, for introducing me for this lecture. So basically, now in this my second lecture, I will be talking about entrepreneurship in COVID era. Okay. So before moving to the entrepreneurship, so in COVID era, I would like to again re-emphasize on the what is the definition of the entrepreneurship. So Tarun has already rightly said about. So actually, entrepreneurship is the process of creating a new enterprise. Process itself is a part of entrepreneurial journey. Okay. So and again, bearing any of its risk, if you create a new enterprise, there is always a risk. So if you are ready to bear that risk, so then you are thinking about the entrepreneurship. And ultimately with the view of making some profit. So when you enter into the entrepreneurship, you are not working for just for free or something like that. You always have something in your mind in terms of as a profit. So it profit could be a money, a reputation, or social reputation. It could be anything. But again, when you are talking about the entrepreneurship, you always have something in mind as a profit. So now next question is like, who is an entrepreneur? Okay. So as a standard definition, the person who creates a new enterprise, of course, anybody who is creating a new enterprise, who is starting a new business, yes, he is entitled to be an entrepreneur and embraces every challenge. Because when you are talking about the entrepreneurship or the new business, it's always comes with a package. So you will have some positive, you have some negatives. So you should have the ability to accept your success, your failure. You should enjoy the journey as well, and you should be open to learn new things as well. So if I talk in personal level, I would say entrepreneur is a person who always thinks every disaster is an opportunity. Okay, so we have seen the COVID era. So now I'm shifting to the COVID era. So we have seen the COVID era. I know there were many businesses who just turned closed, and there were many professions that were not functional at all during the COVID era for the last whole year. But again, like the entrepreneur is a person who was able to handle this COVID era in a positive manner and in an organized way. So like there were multiple opportunities in the COVID era as well. Like we all know that the Indian government is already running a strong drive for Make in India. Okay, so when you are talking about Make in India, so you are all actually talking about the entrepreneurship. The only change is just the COVID era. If you can think something about what is the COVID era is going to, if you can plan how it will look like over time, how the business will go over time, then you can just take the opportunity for dealing with this as well. So that way you can turn this disaster as well into an opportunity. So just to give you an idea, like what are the opportunities actually still available in the domain. So we all know that like in COVID era, protection was the first step to deal with the disease. So they were the huge need of the PPEs. So like PPEs include many things: gloves, glasses, shoe cover, Tyvek suits, etc. So this was a very good opportunity. If you can think something into that, either you can have a manufacturing system, or you can you can plan to provide the raw material or something like that. That would have been the one of the very profiting idea in that direction. Same line, sanitizer is there. So as being a biologist, you can think of making or producing manufacturing at large scale, small scale sanitizers as well. We all know that the sanitizers is a very small recipe. Okay, that is also available at various places. Like you can download the recipe of the sanitizer from the WHO website, and there are a number of websites that gives the recipe for the sanitizers. You can plan, you could have planned, entrepreneurs have planned for these kind of things. And again, the IT tools. Okay, so there were many things where in the IT domain you could an entrepreneur can plan about during the COVID pandemic. Then the next point was about the diagnostics. So in diagnostic area, we all knew, as being a biologist, we knew that whoever is having disease, they will be needing this sampling tools. So like the simple test tube or something like that was the requirement in this era. Okay, so once you have collected the sample, then the next point was transportation media and the tubes. So if you are collecting some samples, you will surely need some kind of media to put that nasopharyngeal swab and all those kind of things. So you could have think about producing those media itself. So the recipe is again available on various public domains. So then next comes is the diagnostic reagents. So we all know that the PCR was one of the most commonly used diagnostic for the COVID. So we know that for performing this COVID, you need master mix, you need tips, you need tubes, you need RNase free water even. Okay, so lateral flow, you need lateral flow cassettes, wicks, absorption pads, anti-human IgG or IgMs, dropper bottles. So they were for ELISA plate, you need plates, tips, blockers, substrate. Those kind of things were there actually. So these were the very open opportunity, and they were not like very new to anybody who is already reading biology or who is already in the field of life sciences. So like the thermal scanners, those kind of things were already there. So opportunities were there. The only thing is that we have to think little differently. We have to think this disaster as an opportunity. So now if we talk to, you want to talk about the therapeutics. So for the entrepreneur, again, therapeutics domain also has many things where they could have think of making profit. Okay, so like drug repurposing. So majority of the, or I would say the whole globe was working on the drug repurposing. So this could have been the one of the option as an entrepreneur. And herbal extract drugs, like we already know, Ayush Ministry is already working on those kind of things. Coronil from the Patanjali, they have used tulsi, ashwagandha, and those kind of things. These were always in front of our eyes. The only thing is we have to think about like an entrepreneur. If we are talking about entrepreneurship, okay, so in the domain of the vaccine. So when you say okay, vaccine is required for dealing with the COVID pandemic, so then first requirement for the vaccine was like the potential vaccine candidate. We already know that there were few coronaviruses already in the system, so we could have already targeted using bioinformatics approaches some potential candidate or the biomarkers or the candidates for the vaccine. And then again, like if you need a facilities, procedures for animal or human studies. So okay, so if you already know the biology, you could have dig down what are the potential SOPs that could have been followed or that are needed to be followed in performing these animal or human studies. Like if you are talking about the animal studies, you would need certain procedures. So if you can think of what are the needs, then you can have a good entrepreneurial venture. Then large scale manufacturing and its associated raw materials and tools. So when you are talking about the vaccine has to be built at a large scale. If we are talking about India, it's a huge population, you need a huge number of doses. So then you need a container for it, you need something to transport this vaccine, you need some places to store this vaccine as well, and then vaccination tool itself, you need syringe, and all those things are required. Okay, so and then if you are already have the vaccine, so next step is going to be like how you will test whether this vaccine which you have used is really efficacious. So this market is still there. So now the only thing is like I can understand that COVID has destroyed many businesses, where many entrepreneurial ventures as well, but again there were opportunities, and there are still opportunities which can be taken forward at this moment as well. So from my side, COVID era itself was not only a disaster, it had some opportunities as well. So, and if you really want to be entrepreneur or if you are ambitious, again, you have to think with the different glasses or different lenses in your heads. That's all. Thanks.
Thank you, Dr. Neeraj. Thank you, Dr. Neeraj, Dr. Tarun, and Dr. Chandresh for that very valuable talk about the entrepreneurship and the product development. See, the thing is, we should be open to learning. We should know what are the market needs, and that is how a successful entrepreneur is born, or he or she successes in his or her field of entrepreneurship. Now we'll have a virtual lab tour. I would request all the participants to be ready with their questions. After the virtual lab tour, we will have a question answer session. So this virtual lab tour will give you a brief idea about the what is the kind of work or what are the facilities that we have at THSTI.
Our mic is on.
And I'm a technologist, and I look after or in charge of technology course.
Camera is
Basically, I
on
just
or
want to give you an
mic
idea
on.
about the technology program as well as the technology course, what is actually being considered by the facility. So basically, technology is a subject which is actually underlying in every single area. So basically, to understand the disease biology, it's very important to understand the technology of the disease. So therefore, we utilize various platforms what we have created in this
THSTI, whether it's the animal platform, because we have to understand the disease biology at the physiological level. So therefore, we need to have various knockout and transgenic cells by which we can address the question at the molecular level. And you can see this immunology core, these are the vaccines, which is the soul of the immunology, in which what we can understand, we can understand the various stages of immune cells. And perhaps you may be aware about this, we have various kind of immune cells in the body, and innate immune cells as well as the adaptive immune cells. And these cells operatively actually make the immune system and play a major role in protecting us from various diseases. I will give you example of SARS-CoV-2, and as we know that COVID-19 is a recent pandemic happened all over the world, and the immunology core is trying to understand how this virus actually induces the immune response. Understanding the immune response against SARS-CoV-2 is not only important to understand the disease pathology or physiopathology of the disease, at the same time, you can also understand the protection correlates of the disease, which could be utilized later in vaccine design, in vaccine immunogenicity. So therefore, using this immunology code, we are trying to create platforms like diagnostic platforms, which is the cell-based platform, and then as well as we are also having the immunogenicity lab that we can collect the blood and the PBMC of infected individuals and can tell you that how many SARS-CoV specific T cells you have, and that will determine the longevity of the anti-SARS-CoV-2 immune response. Thank you very much.
So once you have identified your protein of interest as antigen or the antibody that is going to be used as the binder for your diagnostic assay, you need to produce it at a larger scale. So on large scale culture, we use bioreactors. So we have two bioreactors at the moment. So one is for the bacterial culture, and second is for the mammalian culture. So when you want to produce antigen, you typically use bacterial culture for this purpose. And when you want to use antibodies, then you need mammalian culture systems. These are the two bioreactors we have at our facility. Okay. And each bioreactor has 4 independent culture vessels with working capacity of 2 liters, and each culture vessel can be regulated independently. Okay. So that means we can control the temperature, pH, dissolved oxygen, level of each vessel independently. These boxes are the control element for the different parameters, as I said, temperature, pH, and dissolvent oxygen. And the bottles are for maintaining the pH. One bottle has base solution and another has the acid. So in overall, we can use 4 different flows at a time using this one bioreactor.
In the current scenario, protein production, purification, and characterization are very important for development of diagnostic as well as therapeutic materials. The requirement to isolate or scale up specific proteins at high purity in short timelines have become more challenging due to complex chromatography conditions as well as methodologies associated with this. In order to circumvent all these, we have a machine called actor purifier system, which is a chromatographic system specially designed to help the users, either beginners to experts, for easy isolation of their target protein, whether under simple or complex conditions. We use different types of columns for protein purification, as well as different buffers are also used, which are passed to the column by the inlet. This system monitors the pH, flow rate, and other parameters in real time during the purification process. Also, the pure proteins are collected in different fractions in an automated manner through fraction collectors. The pure protein is further analyzed over the STS page for its purity as well as integrity.
Researchers like Dr. Tarun Kumar Sharma are doing pioneering work on the accurate diagnosis of tuberculosis meningitis, has helped us get a comprehensive understanding of the diagnosis of this disease. They have developed a technology called aptamer, which can detect TB meningitis with excellent accuracy.
We have developed novel diagnostic tool called aptamer. So aptamers are synthetic nucleotides or aptamer-based or RNA-based molecules that fold into a three-dimensional shape and bind to its target with a high affinity and specificity. It is simply in vitro evolution process. And being a synthetic DNA, it has a high shelf life in comparison to the protein-based molecule antibody. And they have high affinity, specificity, and they are cost effective also. And you can adapt it to a various.
The generation of robust binders, either antibodies or aptamers, need their scrutiny for identifying the best fit amongst the pool. So we have a Proteon XPR36 system, which has inbuilt surface plasmon resonance optical biosensor for analysis of interaction between ligand and their specific binders. This provides a real-time data on the affinity, specificity, and kinetics measurement of the interacting partners. The interacting molecules, such as ligand and specific binder, generate specific sensogram as a final result for analysis. On the successful specific reagent generation as a diagnostic intermediate, such as antibodies and antigen, the assay development is required, which essentially needs precision at every step of the assay. So we have an automated high throughput liquid handling system
For performing each step, such as dispensing reagents, incubation, washing, and other essential procedures in the multi-well format assay development.
So when you have purified your antigen or antibody, we need to now work on developing prototype. And in this case, I will be talking about lateral flow assays. For lateral flow assay, first of all, we need to spot the protein on the membrane optimal for your assay. For this, we use the nanoplotter machine. The nanoplotter is a very high-end machine. It has very minute needles that can pick protein samples in nanoliter volumes, cleans the tip, and then spot the protein on the membrane in the format you need. For example, line format or the dot format. This equipment is compatible with various surfaces like paper, nitrosoluble membranes, PVDF membranes, or the glass surfaces. The user has to just write a command and the nanoplotter will spot the protein of your interest on the surface as you want. The second step is designing lateral flow cassettes using 3D printing. So lateral flow cassette is the plastic device that holds the membrane in place in the lateral flow assay and helps in protecting its reagents or the sample loaded on it during its execution from human cells as well as other exposures. So these cassettes are designed as per the need of the assay. For example, they may be single well or double well, contain single stick or double stick, or may have single side well or both side well, depending on the need of the assay. So 3D printing is a process of manufacturing physical objects, in this case lateral flow cassettes, from digital files designed using specialized software like AutoCAD using a 3D printer. So this is the process we use to design these cassettes.
Welcome to the MBSU. So here as you can see, we are using the EMR platform for sequencing of the bacterial genomes in our lab. So in this EMR platform, we are using the MySet platform to sequence the bacterial genome. The MySet platform gives us around 15 GB of output data with approximately 25 million genes. So as you can see that we have already completed this run. So while the run it goes on, you can also monitor the run on real-time basis using some softwares like THSTI Hub. So from there you can actually monitor your run while the run is actually going on. So this machine it has some advantages for small quantities as it has a rapid turnaround time with a runtime of say around 48 hours to 72 hours depending on the number of samples you want to sequence. Then it is user friendly as well as it is very economical. Yeah, it is very much economical. As we are glad to tell you that in our till date, almost more than 400 samples are sequenced using this platform. And we say
here we have SciEx triple drop 5600 mass spectrometer, which is connected to Expert NanoLC 400 unit. It is a high performance liquid chromatography unit which injects the sample into the mass spectrometer. Now what it basically does is, with every injection, it takes a specific amount of sample using the auto sampler that is passed through the C18 tank column. As the solvent moves through the C18 tank column, a very regulated amount of the digested sample reaches the mass spectrometer. This not only gives us the accurate retention time, data which is not only beneficial for many biomedical studies that are going under the domain of human health sciences, but has also given us very crucial leads in the biomarker detection. In the field of proteomics, a mass spectrometer is a revolutionary tool which enables the user not only to quantify but also to identify the proteins which are present in a particular biological sample. The digested proteins are broken down into their respective peptides, which are then ionized and recognized by the mass spectrometer depending upon their respective mass to charge ratio. A typical mass spectrometer has three components: the ion source, the flight tube, and the detector. The peptides of the ions with the lowest molecular weights make it to the detector first.
Okay, I'm going to explain you how to tell you about NMR instrument. So this is NMR instrument that we use in organic chemistry to characterize new molecules. So this is the workstation that we use to have our spectrum, and this is the central console, and this is the main instrument. So we have magnet, and which is supercooled by liquid helium as well as by liquid nitrogen. So the basic principle of NMR is that many nuclei has a positive charge as well as spin, and whenever there is an external magnetic field, the nuclei will absorb energy and they will resonate based on that magnetic field. So you put a sample of your chemical solution inside this instrument and you end up with certain signals, and those signals are then interpreted based on your chemistry understanding, and which can lead to the determination of final structure for your chemical compound. So it is something simple. So you will end up seeing different kind of signals, and based on your chemistry understanding, you can determine the chemical structure based on these different kind of signals. So we call this as NMR spectrum. Thank you.
Hi everyone, welcome to our infectious disease research facility. To enter IDRF, we have a controlled access for trained personnel only. Before entry, we make sure that we are all prepared to work in DSL-free lab, which includes donning PPE, that is personal protective equipment, which comprises of gloves, shoe cover, head cover, N95, coverall, and we are now ready to work inside PSL-3. Inside PSL-3, the circulating air is under constant negative pressure to ensure safety while working. There are 4 hoods in the main filtering area that are provided with HEPA filters and exhaust systems. While working inside hoods, we maintain a clean area to keep our accessories and a dirty area where we handle packaging strains. The lab is well equipped with instruments required for routine culturing purposes. Example, incubator shakers, which are provided with UPS backup systems, incubators, fluorescence microscope, and a ELISA reader, and a desktop computer, table centrifuges, for communication purpose, we also have a small telephone inside. For in vivo studies, we have a dedicated animal facility where small animals are housed in individually ventilated cages in accordance with Institutional Animal Ethics Committee guidelines. Different animals, small animals are kept. For example, mice, either Balsi or C57 track six, guinea pigs, and hamster. We also have an inbuilt double-door wall autoclave system for autoclaving and disposal of biological waste. We also have a dedicated procedure room for performing in vitro animal experiments. This room has an aerosol machine, a separate hood, and a UV pass box for exchange of small activities. So this was a small glimpse of our IDLF lab. Thank you.
Small animal facility at THSTI was established in compliance with the CPCSA guidelines with the support from Department of Biotechnology. Total built-up area is around 5,000 square meters, spread over ground plus 3 floors. CCTV surveillance monitoring is in place. Access to the facility is restricted and controlled through the access control system. Here you can see the facility has the dedicated change rooms to wear the required PPEs and air showers are placed at the entrance. Small animal facility is aimed at providing support to researchers of biological sciences at THSTA and RCB, perform animal studies through the routine breeding, maintenance, and supply of required lab animals. The facility has the dedicated lifts to approach to the respective floor. The ground floor of the facility serves as the support area to the remaining floors. Facility has the clean and dirty point of system interface to avoid the cross-contamination. Here you can see the green corridor. Each floor has 5 animal rooms and dedicated procedure rooms. Each floor has a capacity to house approximately 20,000 to 25,000 mice. Animals are housed only in individually ventilated caging system. And the room has the dedicated cage changing stations required for performing the cage activity or any other animal. Here you can see the mice IVC system and IVC is used for housing the mice. Necessary precautions were taken to avoid contamination as well as infection to the house animals. The facility has the dedicated procedure rooms equipped with the necessary equipment such as anesthesia system, euthanasia system, biosafety cabinets, and also in vivo imaging system is in place. Dedicated service lifts are available for clean and dirty operations. And facility has the green storage area. Here you can see the green storage area. This is the clean processing area or unloading area. Here you can see the cage and air washer as well as 2 double door autoclaves. The facility has the 3 storerooms to store the required accessories and consumables such as feed, bedding material, and other items required in the facility. Here you can see the wash area of the facility equipped with the automated cage and deposit for washing operations, two double door autoclaves for autoclaving purpose, and other necessary equipment such as bedding disposal station, etc. This is the service lift used for dirty operations to bring the used material to the wash area from the respective floors. And this is the dirty corridor, which is U-shaped, and it connects to all the animal rooms. And each animal room has two doors. One opens in the clean corridor and another opens in the dirty corridor. This is the in-house quality control lab available in the facility with necessary equipments for performing the health, genetic, and environmental monitoring related activities required in the facility.
A biobank is a biorepository that stores biospecimen with standard access policies, protocols, and governance as per international guidelines. Biorepository at THSTI has a mandate to store and distribute biospecimen with ensured sample integrity. We at THSTI Biorepository are involved in collection, processing, storage, and archival of various biospecimen under different clinical research studies. The equipment and standard operating procedures for anonymization through unique identification code method are well placed. Timestamp audit trails are generated for quality assurance of lab parameters and storage management. These processes are conducted by trained and certified lab personnel in good clinical lab practices and ISO certifications for quality management. Through a structured governance, these samples are retrieved and shared with different labs across India for research and development purposes. Biorepository was established as a component of Garbija, a DBT India initiative, and houses more than 10 lakh biospecimens, including blood, saliva, urine, high vaginal swabs, and dried blood spots from around 8,000 pregnant women. During COVID-19 pandemic, it is recognized as one of the National Bioresource Center for COVID-19 by Department of Biotechnology and Government of India. We plan to extend our services to NCR cluster to tackle pandemic situations by integrating into existing preparedness plans with developing infrastructure and biorepository.
I hope you all have enjoyed the virtual lab tour. It must have all given you an idea of about the various facilities which we have at THSTI. We have got some very interesting questions from our very inquisitive participants. I would start taking them one by one. We'll not be able to take the whole set of questions, but we'll be talking about few questions only. The first question is science is the greatest collective endeavor. So how can government help to make sure to leverage its role in future as well? I think
Okay.
Dr. Suchitra can answer.
Yeah, so as I mentioned in the overview slides, one of the most important things that the government is doing is to increase its investment in science, in R&D. And if you listen to Nirmala Sitharaman's budget proclamation, it is of 2021. We are almost nearing 1% of the GDP, and this is really important. We do need money. We do need to invest monetarily in R&D in order to be competitive with other countries in the future, not just in the present but also in the future. And when we were talking about the hike, the pay hike that many government agencies have got recently, one of them is the Genomics Initiative to map India's genetic landscape and also to set up knowledge transfer culture clusters. So along with that, there's also the attempt to investigate the genetic structures of every plant variety for agriculture, next generation medicine, and biodiversity management. So these kinds of objectives not only sort of take care of national interests with the money that is available, but also does it with the latest state of the art technology that puts India on the world stage for the present as well as the future. So it's a question of investment of money as well as pursuing the latest technologies that which the government is taking steps to encourage, that will put India on a better platform.
Thank you, Dr. Suchitra. Moving on to the next question, which is an extension of the first one. India is working towards many scientific advancements. So what are the latest steps which are being taken to protect them? How is Government of India protecting traditional knowledge of medicine from patenting? I would want Dr. Tarun to answer this. Okay, should I repeat this question? This is about the various advancements, scientific advancements which have been made. And so what are the steps which Government of India is taking them to protect them, especially for the traditional knowledge with
So,
respect to the patent?
So Government of India already have the Ayush and Siddha department, which take care of traditional medicines and our traditional heritage. So they are promoting to protect all these informations through patent, because some of this information is already there in the literature. So these departments are taking care and documenting it very well, and using this information, if somebody is doing new research or generating new knowledge, then government is promoting to protect this knowledge through patenting. So we can file Indian patent and patent in the other country also, like PCT or US patent, and then other patent in the other country. If you want to add, you can.
So for protecting knowledge generated in India, so Government of India has a very clear and a very detailed patent and trademark strategy. They have a dedicated department, a patent office, patent and trademark office, to review all the innovation which applies for a patent, to provide patent protection and to monitor the what should I say, to monitor whether the IP is being protected during the patent life cycle of a particular invention. And so the through the Indian Patent and Trademark Office, basically the government is protecting all the national knowledge, all the knowledge that is being generated in the national labs and the labs, various private labs also in India. As government research institutes, we have a responsibility to file an Indian patent first of any invention, any innovation that we generate in our research labs. So this is also like promoting or encouraging the patent, the invention or the IP to be in India rather than filing for any patent outside India.
Thank you, Shishmita and Tarun. There's a very interesting question that is about, is there any xenobot which have been created in India? And if there is, how can it help us?
So the creation of xenobots is a very radically new technology, and if you look at it online, you will see that it's not there. So the short answer is no, we don't have it. Nor does Europe, nor do most of the developed countries. This was just done last year, 2020, in Tufts University, and they are still sort of developing it into a further, furthering the technology. But the short answer is no. A lot of people don't have it. It's right now restricted to the US, and you can read more about it if you go online and type the name of this researcher, Michael Levine, from the Tufts University, Boston. So that is, I think, the answer to the question. There's also another bit, right?
If it is in, what's the use of it?
So I had mentioned that briefly while we were speaking. What was the intended use of the xenobot? So, and especially for developing countries where there is huge plastic pollution, one of the things that xenobots can help is apparently in removal of microplastics from water bodies. Then there is also getting them into the human body to deliver drugs. That's another application. and then also to remove radioactive litter. So the very things that are being intended in other countries can also be done if it is developed in India.
Thank you, Suchitra. The next question, very interesting. Why are vaccines not 100% effective against COVID-19? Would you want to take that?
So, so just a spoiler. No vaccine is 100% effective.
Yeah.
It's not only the SARS-CoV-2 vaccine. No vaccine is 100% effective because vaccine efficacy or response to a vaccine also depends on individual immune system, their physiology, their capability. So till date, I don't think any of the vaccines are 100% effective, and it is kind of a surreal concept. It's not a real concept. It cannot be done.
Okay, then taking up the next question, is THSTI providing any financial assistance for these startups? Dr. Tarun?
So a short answer of this question is no, but THSTI has its own incubator, and we have incubator there in our NCR Biotech Science Cluster, where company can incubate it at very nominal price, but they have to pay. They can pay from their pocket or through research grant.
So to add to that, under the innovation fellowship that I mentioned earlier, so after a very rigorous review by an expert panel, the products or the ideas which are found viable, which are found to be good and which succeed to go to the next level, some of those ideas will get some support to be taken forward to the next step. So we usually we do not give a complete dedicated fund support, but we get help from other investors. We get help from we get them help from business developers. So you can say that not in cash but in kind. That kind of an ecosystem is there. We help them to establish their startup. We help them to. The other thing is, if there is the technology is developed in THSTI, the developer or the innovator is given the first right of refusal. So that technology, usually in any institute, whenever an IP is created, that IP is usually offered to everyone out in the world. Whoever can give a better price for the technology can buy it for can license it for further development or further commercialization. In THSTI, what we have is the innovator has a first right of refusal. So it is offered to the innovator first, and if the innovator does not want to take it up in a startup, then it is offered to other people. So in a way, even if there is no direct funds or money to be given to establish a startup, there are a lot of other help in kind which helps the entrepreneur, which helps a new entrepreneur.
Now, the next question relates to innovation in our school system. A very relevant question. Why are we unable to create a culture of innovation in our school system?
So, I mean, it's not a simple question at all.
I know.
There are multiple, parameter which has contributed to this. But briefly, I would say that one thing that in order to be innovative, you have to embrace the culture of failure, that we are not doing as per our expectation. So, I mean, if all of you, I'm sure that all of you must have seen a movie called Tare Zameen Pe. So in that, the take-home lesson was that earlier the parent was thinking their son as a worthless, but when teacher came in the life of that student, he has changed its entire life. So here, teacher can play a vital role in inculcating the innovative capability in the students, so they can nurture the innovation. And of course the responsibility should be taken by their parents also, uh, because so that students should not afraid from the failure. And nowadays the culture is changing, and you can see that there are several schools which are promoting the innovation. One in the Ladakh by Sonam Wangchu, which is totally innovation driven school. And then even the government has taken many initiative. The CSIR has recently started the CSIR Innovation Award for the school children. And then even the government of India especially the DBT, has recently distributed the Folderscope, which is a paper-based microscope, which is another innovation product to inspire school student to be more innovative. So, thank you.
Tinkering
And
labs.
yeah,
Tinkering labs.
BIREC and the tinkering lab. So there are many examples.
There are a few more questions. I'll combine them into one question. This relates to the various facilities that we have at THSTI, and are they available to outsiders, specifically to researchers? Someone has asked about the proteomic facilities. Also,
Yeah, so the THSTI equipment or resources are available as a pay-per-use facility to outsiders. There, on our website, there would be a link for AEF, Advanced Instrument Facility. And if you go there, the instruments are listed. Charges for each instrument are also listed. You can book it online, and based on availability of slot, you can anybody can book it from any research institute in India and come and pay and use this facility. And the charges are actually very nominal.
Shushmita, one more going for you. What is the emerging role of AI in combating COVID-19? Artificial intelligence.
So yeah, mathematical modeling and AI, I mean, have played I would say have played a huge role in COVID-19 era, in the pandemic. I would limit myself to comment on whether it's a successful role or a not so successful role, because we have found that most of the initial mathematical modelings about how this pandemic will spread, what will be the wave, what will the wave look like, everything has almost failed. So, but what we see is AI playing a huge role in most of the countries in to help the government in keeping a track of the pandemic and take appropriate measures. In our country specifically, we have seen Arogya Setu. That's the mostly used and the most important use of AI in this pandemic. Apart from the Arogya Setu, there have been a lot of websites, lot of I would say a lot of predictors or monitors who have been keeping a track of the pandemic, collating data from all over the country. Apart from what ICMR or Ministry of Health is doing, these are all individual servers and individual vendors who are doing it, and giving a very useful analytics of the trend of how the seroconversion is playing out, of how the total pandemic is playing out in the country. So apart from that, immediately a lot of other AI efforts are in R&D stage, which are like from chest radiography, how you can predict whether this particular person, whether this person infected with SARS-CoV-2 will go into a pneumonia stage or not, and all. So those are research projects going on in different places, in different institutes in the country. Otherwise, what we have seen to be successfully implemented is are the apps, are the websites which are tracking the pandemic.
The last question that I would take up is a very interesting and very relevant. What progress Indian women have made in the recent years in context of science?
So, I mean, due to the paucity of time, I have not included many names in my presentation, but clearly there are many women who has actually contributed significantly to the Indian science. So I can name few. So one is the Asima Chatterjee. She has contributed towards the development of epilepsy drug. Dr. Indra Hinduja, she was a great gynecologist and infertility specialist. She has contributed, significantly towards in vitro fertilization and treating the infertility. Dr. Subha Tole, she has contributed for the neuroscience. And then Dr. Aditi Pant, she was a first female oceanographer and geologist in the country. And Dr. Indranath from AIMS, she has contributed towards understanding the biology of leprosy that has helped in treating the disease in a better way. So there are many other names also.
Thank you all. Heartfelt thanks to all the participants. We have come to the conclusion of our virtual Science Setu program. Thank you to all the participating colleges, universities, students, and also to the faculties and scientists from THSTI. I hope it has enriched your knowledge base. Thank you so very much.